We've got Ajay Gupta from Department of Motor Vehicles and Sandeep Midha from IBM. They're going to be talking about how Gen AI-powered innovation helped DMV and other government agencies, like IRS, unlock decades of legacy knowledge to accelerate modernization. And I know a little bit about this, and I'm still excited to hear about it because this is something really relevant to most of us across our program. So come on up.
So I'll start with a story while they're setting up the presentation. So when I joined the DMV in 2019, leaving the private sector, I think somebody intentionally made sure that they tried to intimidate me when I came to my office. They brought a huge chart. It was this wide, literally. And it had a list of all the batch jobs, the architecture which talked about the assembler code, the COBOL code, and these things called runtime controller, essentially an old version of what you'd call, convert something from like a file-based system to a relational system, pseudo-relational system. Little did they know that they cannot intimidate me with the assembler code because I did learn that proudly in college. Anyways, but the problem was real, that we have software sitting from like as old as 60 years actually at this point in time. We have vSAM files, natural database, DB2 that actually has vSAM file database in it, and then the DB2 systems that are running in COBOL programs, run by assembler, etc. And while I gotta give it to the people who built it, it's still running and it's running great, except we are afraid of touching it. We don't know what else we're going to break. We also are worried about, or were worried about, because we have already started the journey to modernize, was how are we going to support it going forward? Like how are we going to enhance things? We need to take it to bring it to this century. Customer who's looking for a mobile solution, how much of a facade can we create around this legacy core before it becomes problematic, before it's no longer nimble? So we came up with some transition architecture criteria. We came up with, meaning we would put facade around the legacy, but the customer wouldn't know the difference. So essentially, make it before we truly make it, or fake it before we make it in a way. The idea was to transform while we modernize. So we started that journey. But now here we are, starting the modernization. We're converting all our platform into Salesforce-based technologies, all our transactional platforms that are customer-facing. But the problem still remains, what's in our legacy code? Do we know it all? Do we go back to our policy documents, or can we take some that we have, that knowledge, the wisdom that's been around for 56 years? So we started to take that. So therein came in the challenges, which you see on the board here. The biggest one was, what's in it? Right, so that's sort of the middle bullet point, the clarity on the legacy business rules. Euphemism for, I'm not sure what's going on. I would really want to know. Otherwise, we all get fired because we go live with the new system and you miss a big policy and sort of have legal issues with it. We also wanted to use something which will allow to sort of meet the old and the new, the old way of doing business, write the test scenarios with the new world, but sort of keeping in mind the business rules that have been there. We then focus on people, right? So that's it's sort of technology process side of it. The people side of it is people are leaving, retiring, and in some unfortunate cases actually passed away. So this problem was real for us. And the people who were around didn't know all of it either. We also have dependencies, right? There's these bad jobs, there's these front-end systems, there's these partners that we interact with. What are those dependencies and how do we make sure that we cover it all when we are modernizing? We don't want to miss anything. I can give you an example. When we went live with occupational licensing, which was the first phase of modernization, a single file, which essentially collects data from dealers, tells the system which dealers are sort of like have a legit occupational license to work, and it gets processed every day. We were late by one day and it went to governor's office, right? So those are some of the things that we worry about and sweat the details around as well. And then there is this layers and layers of complexity, which is the version hierarchy part that we're worried about. So we called an IBM consulting team to help us. They brought in their accelerator tools, Gen AI, which is what IBM is going to talk about today. there is phases of sort of maturity that we have been able to accomplish and improve productivity and sort of unlock the legacy logic. So over to Sandeep from IBM Consulting to talk about it.
Thank you, Ajay. Can you hear me? Okay, all right. Hello, everyone. Good afternoon. So I'm going to talk about how we were able to work with DMV in overcoming some of the challenges that Ajay just described using IBM assets and generative AI. But before I begin, I would like to thank DMV leadership because of their openness and willingness in leveraging generative AI. All of the transformation work that we did was possible only because DMV embraced innovation with trust and collaboration. So thank you so much once again. So as Ajay described, the DMV system consists of many mission-critical applications, like vehicle registrations, driver's license, which are used by Californians every day. But the rules that drive these applications are embedded within the programs. And let me, sorry. So they are embedded within the 2,500 programs at the back end, right? And to understand the requirements from the 6 million lines of code, it would take many years if you have to do this manually. So just to give you perspective, a SME who can manually analyze and document the rules from 1,000 lines of code in a week. So to do that for 6 million lines of code, it would take 6,000 weeks. That's roughly around 115 years, right? So now this SME needs help. Do you have any mainframe experts in the room? Very few, as Ajay mentioned, right? That's one of the biggest challenge. But let's say we found 15 to 20 experts whose only job is to read the code and write the requirements. Even then, this would take 4 to 6 years to get done. And this is one of the biggest challenge why most of the transformation projects don't even kick off. But with IBM's asset and generative AI, we were able to extract, translate, and document the rules from 100,000 lines of code in 1 week. And the entire 6 million lines of code were completed in 15 months. And that too, with minimal SME involvement, once the process was established. What it resulted into? 60 to 80% reduction in the manual effort. And the time that the SME saved could actually be utilized on high-value tasks, rather than being bogged by manual analysis, right? So how this all works? And so there are 4 key ingredients, as we call it, right? So we start by reverse engineering the source code into a language-neutral model using IBM Asset. So similar to how a bilingual person can understand many languages, this model was designed to understand and interpret multiple languages under a single platform. So be it COBOL, Assembler, Natural, Adabas, it can understand it all. And then it converts it into a pseudocode, adds business context from business glossary, and then GenAI comes in. Using the large language models and the tailored prompts, it is able to extract the business rules from the pseudocode and translate it into simple English statements that could be understood by the SMEs. Right? And this entire process is iterative, where human is always in the loop. So AI generates, SME validates, and the system learns until it is able to produce the outputs that are accurate, effective, and can be trusted. And all of this is done in a secure way. So our assets do not directly connect to the applications. There is no data that is involved. And the AI works on the pseudocode and the output from the assets. Right? So this was the work that we were able to do so far for DMV in a project that we refer to as Rules Extraction version 1.0. Now, while this information was useful for SMEs, the thought was, how can we leverage this information for other stakeholders within the enterprise? Right? And that is where, with the advancements in AI and our innovation, we were able to generate much more deeper insights from these outputs using the 5th ingredient, that's Agentic AI. So here, the autonomous AI agents are focusing on the specific tasks. Like, for example, business analyst, there is an agent for that whose only job is to create the business rules from the information that is available. There's a tester agent who's writing the test cases, and so on and so forth, right? And then they collaborate and coordinate behind the scenes to produce the documentation that is rich and much more user-friendly than we were able to produce in version 1.0. And let me show you with a quick video of how it looks like. So here, if you can see, this is how the information gets structured. On the left are the programs. On the top, you can see the outputs that are generated by the AI agents. And on the right, there is a chat assistant that is available. So what basically I want to show here is how the information gets structured and available within this framework. So like the data models, if you see, it can give you the visualization of how the data is structured within the system. It creates the mermaid diagrams. It puts the information in a structured way, in a plain English, that anyone is able to understand. And then, while we understand it's difficult to digest so much of information, so there is a chat assistant that was built on top of this, where you can just query, and it will respond in a natural language. If you want to understand what does a particular program do, you just question that, and it will respond to you with the details. If you want to understand how a particular policy is coded in the system, you ask, and it will respond, right? So what it does, it created the institutional knowledge that is accessible by everyone within the organization. And all of it was done just by using the first ingredient that I called out. Anybody remember? What is that? What was that ingredient? Come on. Source code. Thank you. Thanks for paying attention. So source code. So all the things that we just saw was built starting with the source code. So IBM's innovation and the AI-powered solutions converted this legacy complexity into speed, transparency, and a trusted source of information that can be accessed by everyone. And this is going to provide multi-fold improvements in productivity, much more than what we could gain with version 1.0. And we can now build the modern systems faster and intelligently using AI. Thank you.